Hello students, today we are going to continue P block with group number 17. As we know, group P block is made up of group number 13, 14, 15, 16, 17 and 18. Group number 13 and 14 are the part of syllabus class 11th and rest of the group 15 to 18 are the part of the syllabus class 12th. As we have completed 15 and 16, so today we are going to start group number 17. Group number 17 is called halogen family or halogen series. In halogen family, there are following elements: fluorine, chlorine, bromine, iodine and acetine, in which fluorine is a gas, chlorine is a gas, bromine is a water, iodine is a solid, and the last one is a radioactive element. So we don't know what is the color and what is the stage. Fluorine is yellow color, chlorine is yellow-green color, bromine is brownish red liquid, iodine is violet color crystal, and last one is cause being a radioactive element, it is not available in free state. These all, their general electronic configuration is ns2np5, where n is the principal quantum number which represent the group of the element. Fluorine and chlorine are fairly abundant, while bromine and iodine less so. Fluorine is present mainly as insoluble fluorides and fluoroapatite. Small quantities are present in soil, river, water, plants and bones and teeth of animals. Seawater contains chloride, bromide and iodide of sodium, potassium, magnesium and calcium, but it mainly sodium chloride solution. What is the electronic configuration of the p block element? As we know, ns2np5 is the electronic configuration of the p block element, where n is the principal quantum number which will represent the period of the element. So fluorine is the atom has the atomic number 9 and configuration is 2s2 2p6. To represent, it is the member of the second period. Chlorine atomic number 17, electronic configuration 3s2 3p5. So it is the member of the 3 period. Like this, other elements also follow the electronic configuration. Oxidation state and trends in chemical reactivity. Most of the halogen elements show the -1 oxidation state because they want to complete the octet of the element. They have the 7 electron in the outermost subshell, and to complete the octet only 1 electron is required. So oxidation stage is -1. But in the first excitation state, oxidation stage is +3, second excitation stage +5, and third excitation stage is +7. What is the reactivity? The reactivity means acceptance of an electron is the reason for the strong oxidizing nature of halogen. Fluorine is the strongest oxidizing halogen and it oxidizes other halide ions in solution or even in the solid phase. In general, a halogen oxides halide ions of higher atomic number. Reaction with metals and non-metals. As we know very well, halogens are the non-metals because they have the tendency to accept an electron and they are present in the extreme right side of the periodic table, while all the metals are present in the extreme left of the periodic table and they have the tendency to donate the electron. Halogen react with metals to form metal halides. For example, bromine reacts with magnesium to give magnesium bromide. Sodium reacts with chlorine to give sodium chloride. The ionic character of the metal halide decreases in the order metal fluoride as the maximum, then metal chloride, metal bromide and metal iodide. Reaction with hydrogen. All the halogen elements have the tendency to make the halide reacting with hydrogen. Reactivity towards hydrogen. They all react with hydrogen to give hydrogen halides, but affinity for hydrogen decreases from fluorine to iodine. Hydrogen halide dissolve in water to form hydrochloric acid. Next is the reactivity towards oxygen. Halogen form many oxides with oxygen, but most of them are unstable. Fluorine forms two oxides OF2 and O2F2. However, only OF2 is thermally stable at 298 Kelvin. These oxides are essentially oxygen fluorides because of the higher electronegativity of fluorine than oxygen. Both are a strong fluorinating agent. What is electronegativity? Electronegativity means pulling the electron in the bond. Oxides. Chlorine, bromine and iodine form oxides in which the oxidation state of these halogen range +1 to +7. A combination of kinetic and thermodynamic factors lead to the generally decreasing order of stability of oxide formed by halogen. The higher oxides of halogen tend to be more stable than the lower ones. Chlorine oxide, Cl2O, ClO2, Cl2O6 and Cl2O7 are highly reactive oxidizing agents and tend to explode. ClO2 is used as a bleaching agent for paper, pulp and textile in water treatment. Why this compound is used as a bleaching agent? Because when it reacts, it gives the nascent oxygen. Nascent oxygen has very less self life. Because of that, it react with the other element and clean the material. So this is used in pulp and paper industry also for cleaning. Next is the oxides. The bromide oxides of Br2O, BrO2, BrO3 are the latest stable halogen oxides, middle row anomaly, and exist only at 2 temperatures. They are very powerful oxidizing agent. The iodine oxide I2O4, I2O5, I2O7 are insoluble solids and decompose on heating. I2O5 is a very good oxidizing agent and is used in the estimation of carbon monoxide. Reactivity of halogen towards other halogens. When one halogen reacts with the other halogen and they form the interhalogen compound. Halogen combine amongst themselves to form a number of compounds known as interhalogen compound like XX-, XX3-, XX-5, XX-7. This type of compounds can be only possible because they have this oxidation stage +1, 1, 3, 5, 7, where X is a large size halogen and X dash is a smaller size halogen. Fluorine is anomalous in many properties. Fluorine has a different tendency in their group. Why? First is the ionization enthalpy. What is ionization enthalpy? The energy required to take out an electron is called the ionization enthalpy. Electronegativity, to pull out an electron in a bond, it's called the electronegativity. Electrode potential are all higher for fluorine than expected from the trend set by the other halogens. Otherwise, the trend should be like fluorine, chlorine, bromine, iodine. But the trend is like chlorine, bromine, then fluorine and last is the iodine. Also, ionic and covalent radii, melting point, boiling point, enthalpy of bond dissociation and electron gain enthalpy are quite lower than expected. The anomalous behavior of fluorine is due to its small size, highest electronegativity and low FF bond dissociation enthalpy. Because size इतना छोटा होता है कि उसको ब्रेक करने के लिए ये ज़्यादा एनर्जी की ज़रूरत पड़ती है. And non-availability of d orbitals in valence shell. Most of the reaction of fluorine are exothermic due to small and strong bond formed by its with other elements. It forms only one oxoacid while other halogen forms a number of oxoacids. Hydrogen fluoride is liquid due to strong hydrogen bonding. Other hydrogen halides are gases. Now we are coming to the chlorine. Chlorine was discovered in 1774 by Scheele by the action of hydrochloric acid on MnO2. In 1810, Davy established its elementary nature and suggested the name chlorine on account of its color. Because we know very well, chlorus means greenish yellow and chlorine gas is available in greenish yellow color. What is the method of preparation? It can be prepared by any one of the following method. Number 1, by heating manganese dioxide with concentrated hydrochloric acid. MnO2 plus HCl gives the manganese dichloride. and chlorine gas. By the action of hydrochloric acid on potassium permanganate, that is KMnO4 plus 16 HCl is equal to 2 KCl plus 2 MnCl2 and chlorine gas. Manufacture of chlorine. Dacon's process. By oxidation of hydrogen chloride gas by atmospheric oxygen in the presence of cupric chloride behave as a catalyst at 720 Kelvin. Electrolytic process. Chlorine is obtained by the electrolysis of brine concentrated sodium chloride solution. Chlorine is liberated at anode. It is also obtained as a byproduct of many chemical industries. What all properties are there? It is a greenish yellow gas with pungent and suffocating odor. It is about 2 to 5 times heavier than air. It can be liquefied easily into greenish yellow liquid which boils at 239 Kelvin. It is soluble in water. Chlorine reacts with a number of metals and non-metals to form chloride. It can react with different metals like sodium, potassium, rubidium, iron, calcium, magnesium, and different non-metals as potassium, phosphorus, sulfur, etc. It has great affinity for hydrogen. It reacts with compounds containing hydrogen to form hydrochloric acid. With excess ammonia, chlorine gives nitrogen and ammonium chloride, whereas with excess chlorine, nitrogen trichloride is formed, which is explosive. If conditions are different, result will be different. If ammonia is in excess, we get the ammonium chloride. If chlorine is in excess, we get the ammonium trichloride, that is an explosive. With cold and dilute alkalis, chlorine produces a mixture of chloride and hypochlorite, but with hot and concentrated alkalis, it gives chloride and chlorate. When sodium hydroxide reacts with chlorine, it gives a sodium chloride and sodium hypochlorite NaOCl and water. Sodium hydroxide, when react with the excess of chlorine, hot and concentrated, then it gives the sodium chloride, sodium chlorate and water. With dry slaked lime, it gives a bleaching powder. It oxides ferrous to ferric sulfate, sulfur dioxide to sulphuric acid and iodine to iodic acid. We know very well, Us shows less valency and Ik shows higher valency, means छोटा नाम बड़ी valency, बड़ा नाम छोटी valency. In this reaction, ferrous oxide converted to ferric oxide. Chlorine reacts with hydrocarbons and gives substitution products. So many reactions can be seen in with hydrocarbons where chlorine react and give the substitution reactions, like methane, methyl chloride, ethene, 1,2-dichloroethane. What are the uses? It is used for bleaching board and pulp, it's very famous, bleaching cotton textile, in the extraction of gold and platinum, in the manufacture of dyes, drugs and organic compounds such as carbon tetrachloride, chloroform, DDT, dichlorodiphenyl trichloroethane, refrigerants, etc. In sterilizing drinking water, we are using bleaching powder tablets for the sterilizing the drinking water. Preparation of poisonous gases such as phosgene, tear gas, mustard gas. Next compound is the hydrochloric acid. Glauber prepared this acid in 1648 by heating common salt with concentrated sulphuric acid. Davy in 1810 showed that it is a compound of hydrogen and chlorine. What is the preparation method? In laboratory, it is prepared by heating sodium chloride with concentrated sulphuric acid. When sodium chloride NaCl react with sulphuric acid, give the sodium hyposulfate, and this sodium hyposulfate again react with the NaCl in high temperature 823 Kelvin, it gives a sodium sulfate. The properties of this hydrochloric acid is it is a colorless and pungent and smelling gas. It is easily liquefied to a colorless liquid and freezes to a white crystalline solid. It is extremely soluble in water and ionizes as a hydronium ion. When hydrochloric acid reacts with water, give the hydronium ion and chloride ion. It reacts with ammonia and gives white fumes of ammonium chloride. When 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid are mixed, they form aqua regia. Aqua regia is a solution in which strong metals can also be dissolved like gold and platinum. That's why this is called a royal water. Hydrochloric acid decomposes salts of weak acid, example carbonates, hydrocarbonates and sulphides, etc. What are the uses? It is used in the manufacture of chlorine, ammonium chloride and glucose from starch, for extracting glue from bones and purifying bone black. Nowadays it is very popular of artifacts and jewelry from the bones and horns. In medicine as a laboratory reagent. Now is the interhalogen compounds. When two halogen compounds react each other and making a compound is called the interhalogen compound. When two different halogens react with each other, interhalogen compounds are formed. They can be assigned generally composition as XX-, XX-3, XX-5, XX-7, where it is well known X is halogen of larger size and X dash of smaller size. So, examples are IF7, CLF, BRF, CIF3, BRF5. Preparation. The interhalogen compounds can be prepared by the direct combination or by the action of halogen on lower interhalogen compounds. Cl2F2, they give the CLF equal volume. When F2 is used in acid, we will get the CLF3. Like other compounds can be prepared. These are all covalent molecules and are diamagnetic in nature. They are volatile solid or liquid at 298 Kelvin except CLF, which is a gas. Their physical properties are intermediate between those of constituent halogen except that their melting point and boiling point are a little higher than expected. Their chemical reaction can be compared with the individual halogens. In general, interhalogen compounds are more reactive than halogens except fluorine. This is because XX- bond in interhalogen is weaker than XX bond in halogen except FF bond. Fluorine is showing exceptional behavior in most of the time. All these undergo hydrolysis giving halide ion derived from the smaller halogen and hypohalide. We know interhalogen has the different shapes. Examples like CLF3 have the T shape and IF7 has a pentagonal bipyramidal. What are the uses? These compounds can be used as non-aqueous solvents. Interhalogen compounds are very useful fluorinating agents. CLF3 and BRF3 are used for the production of UF6 in the enrichment of uranium-235, or radioactive element. Oxoacids and halogens. Due to high electronegativity and small size, fluorine forms only one oxide, as the HOF, known as fluoric acid or fluorohypofluorous acid. The other halogen forms several oxoacids. Most of them cannot be isolated in pure state. They are stable only in aqueous solution or in the form of their salts. Hydrochlorous acid, HOCl, chlorous acid, HOClO, chloric acid, HOClO2, like this. Thank you. Good luck. Have a nice day.